Hi friends, in this lecture we will see PN junction diode in the details. PN junction diode has the diode, di means 2, so it has two terminals, one is the anode, another is the cathode. So as it is having the two terminals, this is called as a diode and PN junction. So in last my video lectures we have been discussed about the semiconductor material and its classification. The semiconductor materials are classified into the two types, intrinsic, extrinsic, and the extrinsic are classified into two types, P type, N type semiconductor, and that we discuss in details, so you may refer that my video lectures. Now when P type and N type semiconductor material, they will combine together, so it will form one PN junction diode. So this is the P type, this is N type. When P type and N type semiconductor material, they are combined together, so it will form one PN junction diode. So for this PN junction diode, this is the anode and this is the cathode. So anode, cathode, these are the two terminals for the PN junction diode. Now we will see the working of this PN junction diode. As we know, this P-type semiconductor material, the majority carriers are the holes, which are the positively charged, and in N-type semiconductor material, the majority carriers are the electrons, which are the negatively charged. So in N-type semiconductor material, we have the majority carriers are the electrons, and in P-type semiconductor material, we have the positively charged particle, that is the hole. So when they are combined together, so it will form PN junction diode. So I will just draw the simple diagram. P type material, N type material, when combined together, so it will form the PN junction diode. This is the anode terminal, this is the cathode terminal, this is the symbol for the diode, one triangle, one vertical line, and this is the anode and cathode terminals. So this is about the construction for the PN junction diode. Now let us see the working of this diode. The diode is the important component used in the electronics, because the main application of the diodes are the rectification and the switch. Rectification is nothing but the process in which we can rectify your input AC signals. Rectification is nothing but the process in which we can convert AC to the pulsated DC. Remember friends, I am using the word AC to the pulsated DC. Pulsated means it is not a pure form of the DC. Some AC components are present in the DC, so that we can add their filter component, that is a capacitor, and we can remove the AC signals, and we are getting their pure form of AC. So diode will just rectify your AC signals, that is the pulsated form. So some AC component signals are present. So the main application of this diode is the rectification and the switch. So whenever you should remember this, the application of the diode, that is the main application of the diode, it is rectification and switch. And remember, when we are using means what we have the supply in our homes or in industry, that is coming from the MACB, it is in the AC signals. But all the electronics work, mostly 99% electronics equipments works on the DC supply. So the major roles I have with me as AC, but my equipments are working on the DC. So everywhere I have to convert this AC to the DC. So these components, means this diode plays very important role for converting AC to the pulsating DC. Now we will see the working of this diode. So the working of diodes, it can be called as the biasing. The one new terms is there, that is a biasing. So the diode may be the forward bias or may be the reverse bias. Means we can say the diode is in the forward bias or diode is in the reverse bias. Don't get confusion, because the diode forward bias means what? It is the on condition. This is the on condition. For forward bias, the diode is in on condition. So it's just like this. This is the anode terminal, this is the cathode terminals. So anode and cathode, they are getting connected. Means what signal you have this anode, the same signals you can see the signals at the cathode terminals. So this is the same. Means when it is called as a forward bias, It is on, simply you can remember on, and this is the connection is like this. And when the diode is in the reverse bias, so it is the off means there is a no connections, just like as a switch, it is on and it is off, on off. So forward bias means on condition and reverse biasing means off condition. Now we will see the working of this forward biasing and reverse biasing of the diode. So as we know, the in construction we studied this, the p-type and n-type semiconductor material that is combined together, so it will form the p-n junction diode, and this will the anode and this will the cathode, anode and the cathode. Now to work this diode as the forward bias diode, I have connected this anode terminal to the positive terminals of battery and cathode terminals to the negative terminals of battery. Remember, p-type material is connected to the positive terminals of battery and n-type semiconductor material is connected to the negative terminals of battery. Now let us see working of this. So for p-type, as we know this p-type, we have the positive holes, majority carriers, negatively charged electrons, they are the minority carriers, and n-type semiconductor material, majority carriers are the electrons, minority carriers are the holes. Now this is positive, holes are the positive. So as p-type is connected to the positive terminals, n-type is connected to negative terminals, and it will form one junction. When p-type and n-type material they combine together, so it will form one junction. It is called as a p-n junction. Now when it is connected like this configuration, so what happens? The majority carriers holes in the p-type semiconductor material, as it is having the positively charged, so they are attracted towards the negative, means this holes is diffusing like this. So it is positively charged, holes are positively charged, and this is the negative terminals of battery, so holes are getting attracted towards negative terminals of battery, so the hole is getting diffused, hole diffusion I can say. So it is hole diffusion. Now this is the negative, electrons having the negative charge, and this I have connected their positive polarity here, so the negatively charged electrons, they are attracted towards the positive terminals of battery, so electrons diffusion. Electron diffusion. Now the electrons are traveling in this direction, holes are traveling in this direction, so the junction is getting reduced. The junction is getting reduced, so that the current is getting start to flow from anode to cathode as the electrons are moving in this direction. So the current is flowing in this direction. So due to this positive polarity and this negative polarity, the current is flowing from anode to cathode. So anode should be kept positive with respect to the cathode. So anode should be positive with respect to cathode. This is called as a forward biasing of the diode. Now let us see the working of this diode in the reverse bias. In reverse bias, we have changed this or reversed the polarity of the battery. So this is p-type, this is the n-type. P-type is connected to the negative in place of positive, this is connected to the negative, and n-type in place of negative, it is connected to the positive terminals of battery. As we know, the majority carriers are here, holes, so holes are attracted toward negative, so holes are getting diffusion like this, and this is the electron, so electrons are diffusing like this. So there is a large gap is formed between this. So there is a large gap found between the anode and cathode, so the current will not flow from anode to the cathode. So that condition is called as a reverse bias condition. So it will be simply work as the open switch, that is off condition, and this is called as a reverse bias condition. So hope friends you understood this biasing of this diode. So diode, I will just summarize. Diode, it can be worked in the two biasing mode, forward biasing mode and reverse biasing mode. Simply forward biasing mode means p-type semiconductor material is connected to the positive terminal and n-type semiconductor material is connected to the negative terminals. You can remember p positive, n negative. And in reverse biasing mode, or reverse polarity has been reversed, p-type is connected to the negative and n-type is connected to the positive. So forward bias on just like work as a closed switch, reverse bias of work as a open switch. And the main application of diode is a rectification switch. So this is about the construction of diode, biasing of the diode. Now let us see details what is the VI characteristics of diode. Now when I have connected this, this is the symbol for your diode, anode, cathode, and VI characteristics of diode means when the graph is plotted between the voltage versus the current, that is called as a VI characteristics of diode. And the VI characteristics of diode is divided into the two parts, forward characteristics and reverse characteristics. Forward characteristics and reverse characteristics. Forward characteristics means we can say the diode is in the forward bias, and the reverse characteristics is the diode is in the reverse bias. So now in this case, for initially we have applied some voltage, that is initially we have applied some voltage, and after that when the voltage become greater than cut-in voltage, when voltage become greater than cut-in voltage, then the diode, the current is start to flow through the diode. So current is start to flow through the diode. So when the input voltage is greater than cut-in voltage, the current is start to flow through the diode from anode to cathode. Now in reverse bias, when some temperature is kept the constant, so even the I have increased their reverse voltage, but the current is not flowing through this current, that is called as a reverse saturation current, this I0 current. This is the reverse saturation current. This current will not start to flow due to the increase in the reverse voltage, but when it is start, this current is due to the thermal carrier, because this is thermal carriers means some holes and electrons are getting diffused due to the temperature variation, and as the temperature remains a constant, so some current is flowing, that is called as I0, and this current is a reverse saturation current. And once the value of the VBR, that is a voltage breakdown voltage, is reached, what happens? The current will suddenly start to increase, and this current is suddenly start to increase, and there may be the probability that the diode is getting damaged out or maybe getting burst out. So this is the reverse characteristics of diode. Now to particular on the diodes, we have some conditions. So this is very important to understand to application of the diode to work as a rectification and the switch. Just we discuss about the diode forward biasing and the reverse biasing. The forward bias means on, reverse biasing means off. To on a particular diodes, I should satisfy the two conditions, that input voltage should be greater than equal to cut-in voltage. Input voltage should be greater than equal to cut-in voltage. Now what is a cut-in voltage? When the diode is fabricated by combining the p-type and n-type semiconductor, so it will form the p-n junction. It will form one junction. Now to break this junction, because holes should be diffused and electrons should be diffused, holes should be diffused and electrons should be diffused. So to diffuse this barrier junction should get break there, and the barrier junction is break when you apply this cut-in voltage, and the manufacturer can specify these values. So if the 0.6 volt is for the 0.6 volt for the silicon and 0.2 volt for the germanium, and the input voltage, if it is greater than cut-in voltage, then and then only this break junction will get break and the current will start to flow from anode to cathode. Now maybe the condition happen that suppose a diode is constructed by using the silicon, and I have applied the input voltage 0.3 volt as an anode, and anode is kept positive with respect to cathode. Anode is kept positive with respect to cathode, then diode will not start to move. Very important to remember this and to understand this. If this is the anode, this is the cathode, and the diode is fabricated using the silicon, and now I have applied there 0.3 volt. Even though the diode will not start to flow and current will not flow through this diodes, because the cut-in voltage when the diode is fabricated using the silicon is 0.6 volt. So your input voltage should be greater than your cut-in voltage is 0.6 volt. So to break these junctions, I have to apply their voltage, that input voltage should be greater than 0.6 volt. And second, the anode should be kept the positive with respect to cathode. So anode should be positive with respect to cathodes. So these are the two important condition to become or to work diode as the forward bias. So anode should be positive with respect to cathode, and if it is a positive voltage, but that positive voltage should be greater than their cut-in voltage, and this 0.6 volt it is for the silicon, 0.2 volt it is for the germanium. So important this concept, that you can apply this concept when the diode it can be work as a rectifier. So in this lecture we studied what is a p-n junction diode, what is the biasing, the different biasing of the diode, and VI characteristics of diode. So in next lecture we will see the application of diode as the rectifier. The rectifier diode, the circuit which is constructed by using the diode is called as the rectifier, and the rectification, it is a process in which the AC signal can be converted to the pulsating DC. The very important block of the electronic circuit is the rectification, and the diode plays very important role for the rectification. So the p-n junction diode, it can be work as a rectifier and the switch, that we will see in the details in our next video lectures. If you like this video, you can share and you can subscribe my YouTube channel. Thank you.